Hi, welcome to Learning Monkey. I am Raghuveer. In this class, we will discuss about next greater element in a given array. The explanation is completely based on the assumption that you already have some basic coding knowledge. If you are not good at basic coding, please take our course Placement Training for Service-Based Companies in our website learningmonkey.in, then come for the competitive coding. Coming to today's class, given an array of integers, task is to find the next greater element for each of the element in the array. For each of the element in the array, we have to find the next greater element. If no greater element found, place -1. Example, 5, 2, 3, 9, 6. If this is the case, what is the next greater element for 5? It is 9. So it is 9. What is the next greater element for 2? Which is 3. What is the next greater element for 3? It is 9. What is the next greater element for 9? Nothing. So -1. What is the next greater element for 6? Nothing. So -1. This is what we need to place. This is what the output is. But you need to maintain a time complexity of order of n and space complexity of big O of n. So we need to maintain this time complexity and space complexity. Otherwise, writing the code is very easy. So now we will check the logic part. First way is very easy. Using nested loops we can write the logic, but the time complexity is order of n square. Take the first element, find the first identified biggest element in the next right side from this element, right side from this element. Take the second element, find the next biggest. Take the third element, find the next biggest. Take the fourth element, find the next biggest. This is how we can write the loop. We can write a loop inside the loop, but it is going to take order of n square times. But we need a time complexity of order of n. N means number of elements in the list. How you do that? In order to do that, we are going to use a data structure called stack. Why we are going to use stack here? You have to understand that. If you understand that, next time if you get the similar questions, you can apply stack application there. The similar kind of example we already discussed in our basic course when we discussed infix to postfix. Infix expression to postfix expression. So after listening to the logic, you will remember that logic what we used in infix to postfix conversion. Similarly, we are going to use it here. Let's understand the logic. See, why we are using stack means, see, 8, 5 is less than 8, 3 is less than 5, 1 is less than 3, 2 is greater than 1. See, if you reach to the point 2, the first element you have to check is the last visited. What's the last visited? 1. That's why last in, first out. What is the greatest element for 1? It is 2. Whenever you came here to 2, you need to check the last visited node. What's the last visited node? It is 1, which is 1. So for 1, it is 2. In order to maintain that last visited on the top, what data structure you needed? You need stack, last in, first out. That's why the logic stack, the data structure stack used here. Now coming to our actual code. So we will try to understand the conditions needed for a stack in order to achieve our target. So 8, the first element should be pushed onto the stack. You start from the second element till the last element. Second element we consider it as next. Third element, next always keeps the next element. So next is equal to 5. If stack top greater than or equal to next. If stack top is greater than or equal to next, push the element onto the stack. What is the next element? 5. 5 should be pushed onto the stack because it is smaller than the element present on the top of the stack. So we are going to push it onto the stack. So what's the next element? 3. Which is stack top greater than or equal to 3? Yes, push onto the stack. Now stack contains 8, 5, 3. What's the next element? 1. Push onto the stack. What's the next element? 2. See, this logic fails. If stack top greater than or equal to next, no, it is not greater than or equal to next stack top. See, 2 is greater than stack top. If next is greater than stack top, you need to identify the logic loop till we find the smallest element on the stack top. This next value is going to be greater than all the elements that are popped. For all the elements that are popped, this next element is going to be greater than for all the elements that are popped from the stack. Then push the next element. Anyhow, this is not the way to understand. With example we are going to understand. So what's the next element? 2. 2 is greater than stack top, so pop stack top. 1 is popped out. 2 is greater than 3. What is on the stack top? 3. Now 3 is there. Is 2 greater than stack top? No. Pop until you find the smallest elements. For all those smallest elements, this 2 will be the greater element. That is what the logic. This logic we are going to understand in the next step, better way in the next step. So we are going to pop 1 and push 2. What are the elements that are present here? 8, 5, 3, 2. For 1, what is the greater element? 2. Display it. For 1, because we popped 1. For 1, what is the greatest element? Next element is the greatest element. What is next? 2. So for 1, 2 is the greater element. Push the 2 onto the stack. 8, 5, 3, 2. So what's the next element? 1. 1. So push onto the stack. That's why 8, 5, 3, 2, 1. Now you are going to understand what is the next element? 6. 6 greater than what is stack top? 1. So pop out. 6 greater than what is stack top? 2. Pop out. 6 greater than 3. Pop out. 6 greater than what is stack top? 5. Pop out. For all these elements, what is the next greatest element? 6 is the next greatest element. So for 1, what is the next? 6. What is for 2? 6. 3, 6. 5, 6. For 5, greatest element is 6. Now push the 6 onto the stack. So the stack contains 8, 6. We popped out all the smallest elements until you find the smallest element. For all those elements, next is the greater element. After that, at the last, push next onto the stack. This is what the logic you have to understand. Now 8, 6. And one more condition you have to understand. 8, 6. What is the next element? 9. It is 9 is greater than 6. So pop. 9 is greater than 8. So pop. Is there any elements remain in that? No. All the elements are over. So push 9 onto the stack. 9 will be remain. For 6 and 8, what is the greatest element? 8, 9. 6, 9. Now come to the last one. What is the last number is? 1. 1 is not greater than 9. So push onto the stack. All the elements are over. What are the elements that remain in the stack? 1, 9. For these elements, what is the top greater element? -1. No elements are found. So that's why you have to place it as -1. For all the elements that are for all the elements that present on the stack, the remaining elements will be, for all the remaining elements on the stack, the greater element will be -1 at the last. This is the logic you have applied on the last. So this is based on this you have to write the code. So we are going to display the code here. Our suggestion is to try to solve it on your own, then check for the solution. Anyhow, coding is present on our website learningmonkey.in. You can copy the code and you can use it. So checking for the empty stack, we have written a definition. Checking for push, pop, and now coming to the logic. Take a stack S and you do the push operation and pop operation according to our conditions. Hope you understand the example. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.